So this is our third lesson on chapter 12. First of all, we're going to start off with the warm-up exercise. So you might want to find that on your book and then try answering the question. Actually, it just asks you to solve this equation here. Now, it's a while since you've probably done this type of question, so you can see we've got exponents here. Now, when the variable we're trying to find is an exponent, what we're going to do is we're going to do the inverse of that. So we're going to take logs of both sides. Now, the reason we want to take logs of both sides is there's a very key rule we can use of logs. If we have a log of something raised to a power, we can bring the power to the front of the question, and we can actually do that for both of these. Parentheses is very important on this one, because if we don't put that, it means the only thing we're times in log 4 by is x, where actually we want to times it by all of this. Now we can go ahead and distribute this, and as we're trying to solve for x, we're trying to bring all our x's to the same side and then try solving. So if I bring the negative x log 4 to this side, I can now take x as a common factor, and that gets around my problem how I solve for x when there's two x's. So take x as a common factor, and then divide both sides by this, so we get x equals that, and then if we change it to a decimal, approximately 0.77. So quite a few steps on that, something we haven't done in a while. Now today what we're going to do is we're going to look at how to find the distance of a point from a line. Now, we actually do know how to do this already from geometry. If this is my point here, then if I've got this line here, the shortest distance must be at 90 degrees to this line. Now, we're going to take an algebraic approach to it first. So, how far is the line 7, 1 from the line y equals 3/4 of x plus 2? So, we already said that this line here is going to be perpendicular to this line here. So, what I'm really trying to find is how far is it from here to here, given this equation here, and given this a point down here. So if I can find the equation of this line, find where it intersects with this line, and then find the length between those two distances, then that should be able to solve my problem. So first thing I'm going to do then is I'm going to find what the equation of the line perpendicular to the line I'm trying to find. So if it's perpendicular to this, it's going to be the negative reciprocal of this, so it's going to be negative 4/3, but it's also going to pass through 7, 1. So point slope formula, I can multiply this out, and if I rearrange that, I can have the equation in standard form. So I want to find when does this equation intersect with this equation. So that's a system of equations. So I could either make them both say y equals, or I could go ahead and make this one into standard form. I think I actually made that one into standard form. And there we go. So if you rearrange the other equation that we saw, you end up with this. And then if you go ahead and solve that system of equations, then you should find that it intersects with 4, 5. And you might wish to pause the video to take a slightly longer look at this. So when we found that system, we found that it was 4, 5. And remember what the question said. How far is it from that point we were given to this point here? So we're going to use our distance formula, and you should find out that it was 5. Now this question is fine because it's in 2 dimensions, and we know how to do equations of lines on the graphing plane. But what if we change it to 3 dimensions? Then suddenly this gets a lot more complicated. So we need to find a very different method of actually doing this. So we're going to look at that same question, but we're going to do it by vectors this time, rather than the method we just used. Now I'm going to warn you in advance, this is quite complicated to begin with. We're going to do a summary of the steps that I did at the end of this. So take the notes as you go along, and then we'll summarize later. So this is pictorially what's happening here. Here's my point 7, 1. Here's my line 3/4 of x plus 2. And I'm trying to find this distance here. Now the problem is, and this picture might not be perfectly accurate, but it should be a reasonable approximation to what we're trying to find. In fact, I can see this as wrong because this actually has a slope of 1/4 instead of 3/4. But it's some visual so you can sort of see what's going on here. So I'm going to pick a point that lies on the line. I'm trying to really write a vector equation of this line here, really. To do this length here, what I'm actually going to find is I'm going to find this length, and then I can do Pythagoras on that. Now the first part of this, A to B, I can find the length of this. This part here, unfortunately I don't know where this point is, so I can't actually do that straight away. So I'm going to need some clever technique to get around that. So first of all, we pick a point that lies on this line here. And as this said 3/4 of x plus 2, then I know the y-intercept is 2. So obviously one of the coordinates is 0, 2. And I also know we have 7, 1. So how do I get from 0, 2 to 7, 1? Well, I I go up by 7, and then I go down by 1. Or you could say this vector take away this vector, and that will still give you the same answer. The length of this vector, because I want to find the length of the hypotenuse, 7 squared plus -1 squared square rooted gives me the square root of 50. This I'm going to use in a little bit because I want to find these two side lengths to find that third side length. Vector equation of this line, I'm going to need a point and I'm going to need the direction vector. So as it goes through 0, 2, 0, 2 is my starting point, and 4, 3 I got from here. Now remember, for our slope it's rise over run, but when we write a column vector we actually go across first and then up second. So I needed to flip these two over to give me my vector equation of the line. And that's the first part of this done. Now the next part is we're going to look at our direction vector and we're going to make it into a unit vector. So remember, this is your starting point and this is your direction vector. Now the length of this I said was 5, and the reason I said 5 is Pythagoras on this as well. 4 squared plus 3 squared, all square rooted, gives us 5. Now a unit vector is a vector that's length 1. So if it's length 5 and I want length 1, what I'm going to do is I'm going to divide each of these terms by 5. So we find a unit vector for the direction, and we're going to go with 4/5 and 3/5 by dividing each of those two terms by 5. Now at the moment it's not obvious why we're actually doing that, but this is a setup stage for our third thing that we're actually going to do in this question. And what we're actually going to do is this. We're going to look at this problem here. Now we're going to look, we've got our direction vector that we just worked out. We also have our original direction we looked at, how do we get from A to B, and we've got theta. Now if we wanted to find theta, and actually we don't want to find theta for this question, but we could use the dot product. So P dot Q equals absolute value P, absolute value Q, cosine theta. Remember from definitions, and this is the part that you don't really need to understand, but you're going to be using. So cosine theta also equals adjacent over hypotenuse. So you could say that the adjacent equals the hypotenuse times by cosine theta. Now notice that this is actually our hypotenuse, the length of one of the sides, and this is cosine theta. So what I can actually say there straight away is that this is equal to A. Now absolute value of P, notice I made this a unit vector, so the length of this is just 1. So what we have here is actually saying the dot product is actually equal to 1 times A. So in other words, the dot product is actually equal to the adjacent side. And that's really the fact that you need to know. If you want to find the length of this adjacent side, you can cleverly just work out the dot product between these two numbers. So to work out the dot product between these two things, let's write it out here. You're going to multiply these two things, multiply, and then you add the two answers together. So we get 25 over 5, which equals 5. So now we have the length of the adjacent side 5, and we have the length of the hypotenuse, which we had earlier, which was radical 50. And then now we can actually find the length of that missing side. So by doing Pythagoras, we found the length of the adjacent side, we found the length of the hypotenuse, therefore we can find the length of the adjacent side, and you should just check to see that you do agree that it's equal to the square root of 50. In fact, I'm not too sure that is true. Square root of 50 squared minus 5 squared all square rooted is actually 50 minus 25 square rooted. So actually it should equal 5. So actually that's a slight mistake on that slide there. So that the 0 shouldn't actually be there. Very complicated, and in the next clip we're going to look at actually what we did, summarise, and then try a second question.